Now we'll take a look at the GP-RAM versus EEPROM in the PIC chips. The GP, the general purpose RAM, which constitutes most of the file register, must not be confused with the EEPROM data memory. The GPRs are used by the CPU for internal data storage, whereas the EEPROMs or the double EEPROMs are considered as an add-on memory that one can also add externally to the chips. In other words, while PIC chips have 0 bytes of double EEPROM data memory, it is possible for a microcontroller to have 0 size for the file register. The file register of the PIC-18 family can have a maximum of 4096, approximately 4K bytes. With 4096 bytes, the file register has addresses 000 through FFF hex. The file register in the PIC-18 is divided into 256 byte banks. Therefore, we can have up to a maximum of 16 banks. That's 16 times 256 for a total of 4096. Although not all members of the PIC-18 family have that many banks, every PIC-18 family member has at least one bank for the file register. This bank is called the access bank, and it's the default bank when we power up the PIC-18 chip. To simplify how we use the file register in the PIC family, we focus on a single bank that is found in every member of the PIC-18. You can examine the file registers in another PIC family, such as the PIC-12 and the PIC-16 on the Microchip website. Here, we'll concentrate on the PIC-18 series with their large file register, although the insight gained in the process can be applied to both the PIC-16 and the PIC-12. Examine the access bank for the PIC-18 in the figure. The 256 byte access bank is divided into 2 equal sections of 128 bytes. These 128 byte sections are given to the general purpose registers and special function registers, the SFRs. The 128 bytes from locations 00 hex to 7F hex are set aside for general purpose registers and are used for read-write storage, or what is normally called a scratch pad. And you can see the scratch pad there outlined. These 128 locations of RAM are widely used for storing data and parameters by the PIC-18 programmers and the C compilers. Each location of this 128 byte RAM of general purpose registers can be accessed directly by this address. We'll use these locations in the future to store data brought into the CPU via I/O and serial ports. We'll also use them to define counters for time delays later on. The other 128 bytes of the access bank are used for SFRs. It has addresses of F80 hex to FFF hex, as shown in a figure. One might wonder why the memory space of the SFRs and GPRs in the access bank is not contiguous. The reason is to allow the RAM space between 080 and F7F hex to be used for the general purpose registers by various members of the PIC-18 if they implement a larger data RAM size for the file register. A file register of more than 256 bytes will necessitate bank switching. Bank switching is a method used to access all the banks of the file register for PIC 18 family members that have more than the minimum access bank. PIC 18 members with a file register of more than 256 bytes will be discussed later on.